Welcome to Lok Sabha Television. You're watching Climate Matters. I'm Suman Sahai. We have with us in the studio today again two very well-known experts. On my extreme left is Dr. T. Ramasamy, Secretary to the Government of India in the Department of Science and Technology. And to my immediate left is Mr. Ramasamy Iyer, who retired as Secretary to the Government of India, Ministry of Water Resources, is a known water expert, and after his stint at the Center for Policy Research, he has continued his engagement with water issues and water policies. Welcome to both of you. We're very glad to have you on this program. Dr. Ramasamy, let me start with you. There is a huge concern now about climate change and its impact on water. And we know that the countries of South Asia, particularly us in India and Pakistan, Bangladesh, are going to be very seriously impacted, and our water resources are going to diminish or become uncertain. Now, tell me, what is our preparedness? I mean, you as a representative of the Government of India, what is our preparedness for dealing with all three kinds of water uses in agriculture, domestic water, industrial water?
Well, good afternoon. You pointed out yourself that water usage for agriculture, municipal requirements, and drinking would naturally have challenges of both quantum and the quality when there are inadvertent changes under climate zones. One would recognize that the quantum of water required or used in India for agriculture is very high. Mm-hmm. Close to 80% of the water usage is primarily in irrigation. Mm. The quality of water required for irrigation will be markedly different from the quality of water required for drinking.
Certainly.
The quantum of water required for drinking may be smaller, but the quality constraints are very serious. Right. Currently, we depend very heavily upon rain for agriculture and other irrigation purposes, and we have a flowing rivers as well.
And you have groundwater.
Yeah, sure. Now, the type of agricultural practices that we have today, we end up using more of groundwater for agriculture, and there is naturally a competition between drinking water use and agricultural water use as well. There is a challenge of our own kind. Now, given this dimension of climate change, we need to ask, will this climate change affect the sources of water supply? For example, glaciers. If we project forward the kinds of warming that is being projected, one could ask whether the glaciers will melt. Of course, most of the glaciers at a very high altitude. The Himalayan glaciers are very important sources of water, third pole almost. So, under the National Action Plan for Climate Change, there is a specific mission launched for sustaining Himalayan ecosystem, correct, which includes glaciers as an important component. And this particular mission is rooted in the Ministry of Science and Technology.
Right.
There is one task assigned to us to increase the preparedness of this country in terms of water management in a changed climate scenario.
So it's in very competent hands.
Now, the other thing that you talked about is the how prepared are we to manage the water.
Correct.
One is assess, but the other is some management of water. The strategic knowledge for managing climate change is also housed in the Ministry of Science, and Earth Sciences collaborate with us in a very effective way. And Ministry of Environment and Forests, Ministry of Science, Ministry of Earth Science, together are actually providing the necessary framework for developing a knowledge system. That includes water management as well. Having said this, the Supreme Court is very conscious of this huge change of water management problem. Decided to pass a single line order that the water problem of India will be solved with the Ministry of Science and Technology.
This was last year.
Last year. And they have made the Secretary of Science and Technology appear before the Supreme Court every 2 months and give the report. This gave us an opportunity to actually study the problem in totality in India. We have now recognized there are 26 different types of water challenges, both in terms of quantity and the quantum.
Right.
So what we did was to write to various states in the country to recognize those hotspots for the different challenges. We have about 180 hotspots recognized by this model.
So you know where your problems are?
More or less. Let me tell you, in terms of the Ministry of Water Resources will provide some database about the.
And this is what you launched as the war on water, the whole thing.
Sure.
We'll take this up further, Dr. Ramasamy. Let me come to you, Mr. Iyer. Dr. Ramasamy mentioned the National Action Plan on Climate Change, and it addresses in its 8 missions. It addresses itself very directly to water. Let me ask you quite candidly, do you think this captures what needs to be done, or do you think that there are other things that should be included in such a mission document?
Well, let me begin by saying that even if there is no climate change at all, there is going to be a serious water crisis.
Absolutely.
So I have been writing about the transformation that is needed in water policy long before people started talking about climate change.
That's correct.
And one of the main difficulties there is that in the past, water policy has meant water engineering, building dams, canal systems, huge storages, long distance. This is what they thought was the contribution of science to water. As it happens, this has led us down the wrong path for a long time. And in the last decade or 2 decades, it has begun to be realized that this is not the right thing to do. That water is much more than this. Water is not a matter only for engineers. It's not even a matter only for scientists. It's a matter of, when you say science, it includes social science.
Absolutely.
So there are answers which only natural science can provide. But there are answers which only social sciences can provide. And the questions that if you put a social science question to the natural scientist, he can't answer it.
Correct.
Vice versa. This kind of approach, that what you need is a transformation from the old unidisciplinary kind of approach to water planning and policy. You have to change to an interdisciplinary approach.
Has that happened?
It has not happened. We've been talking about it. People are beginning to realize it. And so what earlier we thought was that the essential thing was to provide more water.
Right.
Supply side solutions. Build a dam, build a long canal system, transfer water over long distances.
Right.
Then I have been arguing that if there is going to be a water crisis, it's not entirely because there is a growing population putting pressure on a finite resource. It's essentially because we are grossly mismanaging our water resources.
Right.
So what is required is a transformation of water use, water management. Why is water used? And in that, it's engineering science, natural science, social sciences, sociology, and social science does not mean only economics.
Correct.
See, what has been happening so far is that water has been dominated by a combination of engineering and economics.
That's happened in many other sectors.
So we have to change from this to bring in sociology, social anthropology, environmental sciences, ecology.
And the end users, the people.
Exactly. That's why sociology becomes important. And that is sort of slowly sinking in. And as I said, so all this would have been necessary even if there had been no climate change. What climate change adds is a new sort of element or dimension of uncertainty, great uncertainty. And the June 2008 working group report of IPCC said 3 things: that there is going to be more increased precipitation in some areas, increased drought in some other areas, and increased variability of precipitation, so that you might get the same rainfall or more rainfall in fewer days,
Correct.
creating more problems with floods. Similarly, if glaciers start melting, you might initially get tremendous floods. And after some time, the rivers may dry up. One doesn't know.
Right.
The difficulty is, while we have a broad idea of what climate change means for water, these uncertainties that I mentioned, we don't know exactly what is going to happen when and where.
So the
Now, that
key
is being
word is
studied.
uncertainty.
That is being studied. I think Terry is studying it, perhaps your ministry is studying it. But we don't have the answers
But
yet.
how do you study uncertainty? There's complete randomness
I think
that
you have to. That's what science does. And they make the uncertain into slightly more certain. And the point is that why I am saying all this is, until you know exactly what is going to happen, you cannot devise your answers. There is already a national water mission. It
Right.
mentions a number of things.
Right.
Unfortunately, they haven't got away from conventional thinking. If you see, internationally there is a slogan, integrated water resources management. There are some criticisms to be made of that, but forgetting that, one of the Indian contributions there has been, people have been saying, I have heard it in a number of meetings, oh, we are only talking about management, we must talk about development. So they changed it into integrated water resources development and management. And what does development mean?
Use.
Building more dams. Water resource development essentially means building storages, reservoirs. And in fact, when the World Commission on Dams made its report in 2000, the government of India rejected it. And in rejecting it, they said, we know what to do. We have to build 200 billion cubic meters of additional storage over the next 25 years. And then they brought in this interlinking of rivers,
Correct. Now this
which is, I think, fraught with great danger. It's completely unscientific,
Ms.
foolish
Iyer,
kind
that's
of
an
idea.
extremely important point that you have raised. We will need to take a break, but I'd like to come back from the break to the interlinking of rivers and the river basin management, if you will.
But I would also like to say a word about the Supreme Court's role in this.
Certainly. It's time to take a short break. We will continue this discussion, so stay with us. And we will go back to the issue of interlinking of rivers, which has caused some concern amongst environmentalists. So come back in a bit and we'll see you.
Now, the idea there was really two propositions. One is that we have a lot of floods in some parts of the country and drought in other parts of the country. So why not transfer some of the flood waters to the drought-prone areas, so that providing a little more water to the drought-prone area.
Welcome back. Before the break, we were talking to Mr. Iyer about the less than satisfactory management of water in our country, and he had begun to flag the question of river basin management and the interlinking of rivers. And I remember, Mr. Iyer, when this subject had been raised a couple of years ago, there was a huge comment in the media, and the environmentalists were up in arms. So you were starting to comment on that. Let us hear your views.
Yeah. Well, I don't know whether we should spend much time on that, because at the moment that project seems to be in the doldrums.
No, but it is
But
still
it
there.
was announced. It's not been abandoned. It's
Absolutely.
announced, and it's supposed to be. Even this mentions it. Now, the idea there was really two propositions. One is that we have a lot of floods in some parts of the country and drought in other parts of the country. So why not transfer some of the flood waters to the drought-prone areas, so that providing a little more water to the drought-prone area and moderating the floods to some extent in the
Point
flood-prone
taken.
areas.
But has any studies been done on this
No,
anywhere?
let me come to the second idea in this, behind this project was that there are some river basins which are surplus in water. And there are other river basins, like for instance Kaveri, which are supposed to be deficit in water. So why should we now transfer some water from the surplus basins to the deficit basins?
That is the logic.
These were the two propositions underlying this whole interlinking of rivers project, which envisaged something like 30 links. And it was announced as a great project, the answer
Right,
to
and
India's
then it raised
future needs
all
and
of
so
these
on. And
things.
some people welcomed it on those lines.
So I just want to ask you very quickly before I move to Dr. Ramswamy.
Yes.
What has been the Supreme Court's involvement in this whole matter?
Okay. It was, I think, it was a time of drought, and there was already a case before the Supreme Court about pollution in the river Yamuna, and there was two amicus curiae or amici.
Briefs.
One of them, before that, the President of India, Dr. Abdul Kalam, made a speech and said that there should be a networking of rivers for solving India's future problems. That was picked up by this amicus curiae, and he submitted an application to the Supreme Court saying that there has been a project for a long time. We've been talking about interlinking
But what
rivers,
did the court have to say?
and why is it not happening? What is the government of India doing about it? So the Supreme Court issued notices to the central government and to all the state governments asking whether such a project exists, whether it has been talked about, what is going to be done about it, and whether it's a good idea, and so on. The government of India submitted a very cautious affidavit saying, yes, we are thinking about it, we are studying it, but there are many difficulties, technical, political, financial, and so on.
I see. And with that, they put it into the
And
freezer.
no, and they said, we might do something in about 40 years' time.
Uh-huh.
The state governments did not reply, except for Tamil Nadu, which welcomed it, because it's a deficit area and it wanted water from elsewhere. So the Supreme Court, on the basis of this practically non-existent material, gave a direction. No, if it's a good idea, why do you want to take 40 years? Do it in 10 years' time.
Oh, good God. So is that what we're facing
It's
now?
widely recognized among many commentators, including some of the most eminent legal luminaries of this country, that the Supreme Court went completely berserk on this issue.
So the Supreme Court,
it was not their job, and what they did was completely wrong. But they sanctioned or mandated a wild goose chase.
Well, that's extremely unfortunate.
And then there was a lot of criticism. Then the government changed,
and
the new government said, they put it in their common minimum program, that they would reassess this comprehensively in a fully consultative manner. And after that, there has not been much progress. I think the new government perhaps was not very enthusiastic about it.
So hopefully it's now sitting in the cold storage.
It is in the doldrums, but it has not been given up.
It's not been abandoned.
And it is mentioned. It is mentioned in this.
It's there. It's
yes,
still. It's,
in the
so it's alive.
Yes,
the issue is alive.
Very much alive.
Now that's so disconcerting. Dr. Ramasamy, you mentioned that you had identified during this process of scoping the water problem 26 challenges, and that you had been able to map the areas that were problematic. There is a huge hype about rainwater harvesting, and it is every season the newspapers will carry it, and everybody thinks that the answer to climate change at some very, very fundamental level is rainwater harvesting. I want your reaction to the technology status. Do you think that rainwater harvesting is being done in as sound a way as it is possible? And two, apart from its technology status, is it as cost effective as it can be? Because if it has to be done on such a large scale, shouldn't it be cheaper than this?
See, water challenge is widely varying depending on the location. So whenever we talk about countering a challenge of this kind, our solutions also will be disaggregated to suit a local requirement. Our addressing this question would require multiples of approaches, not one. Rainwater harvesting is certainly one of the important approaches, and we cannot say that that will be a be-all situation. We require more. As far as the rainwater harvesting technologies themselves are concerned, that is again a very widespread. If you look at the mapping of the kinds of rainwater harvesting technologies being implemented in this country, if you carry out a scientific and systematic study, you will see there is a wide difference. In some sense, you have to also accept the differences originating from the hydrological properties of the location, the geological processes, the kind of groundwater transport system will be present. If you ask me whether those factors have been factored into in the designing of the rainwater harvesting, the answer is no.
They haven't.
Some places yes, some places no. We cannot say that it is one way or the other. I mean, generally in our India we can always make a statement, different centuries coexist. The technologies also coexist in different ways.
So there is a scope for much improvement.
What we are doing under this particular study, one of the solutions is rainwater harvesting of this process. I named that program deliberately as a winning augmentation and renovation of water, which is WAR, WAR, for water, not they are positive direction, not against. Now there, when we look at this, each specific zone is being assessed for this hydrogeological behavior, and then develop the storing capacity. Rainwater harvesting has done well in a city like Chennai. Almost every house is complying to the process. So the quality of water improved. Therefore, you should look at it more as a kind of a social approach to conserving water, rather than look at it as an enterprise model. I think that's an important issue.
Two more questions which seldom get addressed when we talk about climate change and its impact on water, or on water per se, as Mr. Iyer said, that with or without climate change it's an issue for us, is desalination and wastewater management. Have we gone into desalination in any serious way? I mean, we do have, what, 6,000 kilometers of coastline, or 5,703 and 36 kilometers of coastline? Are we doing it?
Well, the first desalination plant has now come into operation in Chennai. It's a very large facility that is established. Lot of small units have been implemented over a period of time, the last 20 years, in fact, desalination processes. Desalination in a coastal town is one kind of use, because the reject management becomes easier. If you want to do the desalination using a reverse osmosis route in a landlocked zone, then sending the reject is another issue.
What do you do with that salt concentrate?
Is an issue. There are two technologies which have been done to some reasonable level of credibility. One is the reverse osmosis based desalination path. The other is a low temperature thermal distillation system.
Now, for our viewers, you'll have to say what that is, just very quickly and simply.
There's a temperature gradients in the ocean. There's a difference in temperature between the surface and inside.
It's warmer on top, it's cooler below.
If you have a difference about 8 to 9 degrees, we could take advantage of this temperature gradients between the surface water and the deeper water, and set up a distillation system from the ocean water, which gives around 2 to 2.5% of the water coming from that source, which is drinkable.
So that part of the ocean layer, which has got the least salt concentration, is that what you tell?
No. That is nothing with the least concentration. It's a distillation system.
In the ocean?
In the ocean, inside the ocean. Therefore, what you are doing, when there is a gradients in temperature, and you supply a certain amount of an internal heat energy system, that water evaporates. That evaporated water is condensed and is completely free of salt.
I see. So
we have now a work.
And is this a cost-effective technology?
This particular technology would cost a significant amount of money for investment, but the operating cost is low.
That is hopeful, and if you have such a crisis.
This particular technology has been in operation for 4 years in one of those Lakshadweep Island, Kavadatti. They provide 100,000 liters a day, and this is very welcomed by the community. Community is managing the plant.
I'm sure. That sounds very hopeful for us now. Mr. Iyer, a political question. We have problems with our neighbors on both sides, with water issues anyway. With climate change kicking in, you will have an exacerbation of these issues because there will be less water to share. Have we started any process of negotiation with each other on the left of us and on the right of us, with Pakistan and with Bangladesh? Have we begun to anticipate jointly that we will be facing this, and how can we face it together in the future, or do you see a conflagration coming?
Well, so far as I know, I don't think we've been discussing this seriously with our neighbors. One doesn't, as I said, one doesn't know what's going to happen. Now, for instance, suppose the glaciers start melting. You may initially have a problem of tremendous floods.
Yeah, but you can anticipate the both.
Later on, it may become a problem of shortage. One doesn't really know. What is important is that, and then it has, it has an impact on coastal areas, low-lying areas. Some are exposed to from Bangladesh. Part of Bangladesh might go underwater. What is required is, therefore, that all the countries, it's not bilaterally to be discussed, but Pakistan, India, Nepal, Bangladesh, Bhutan, we
all should sit together
and find out what is going to happen. What is the impact of climate change?
I would say that if you have a flood, what do we do?
Unfortunately, it's not begun to happen yet.
Right. No, I mean, the contingency planning, I imagine, would be if we have floods, what do we do? If we have droughts, what do we do? If the water increases, what do we do? Water decreases, what do we do? We have very little time, and I'd like to ask both of you in 30 seconds on where in water would you place your number one priority as your response to climate change? Just one quick point.
I think we should focus on technology for demand management, much more effective than what we are doing.
Mr. Iyer?
I agree with that.
That makes it easy. So we need to manage our demand if we are to cope with principally the uncertainties of what climate change will do to our water. Thank you very much, Dr. Ramasamy. Thank you very much, Mr. Iyer. It's been a pleasure to have you both. That was Climate Matters, discussing the impact of climate change on water with two very knowledgeable experts. We will end this program now, but before we do that, if you have comments, queries, responses, please mail us at climatematters@gmail.com. We wait to see you at the next program, and until then, goodbye.